What's up, everybody? In this video, we're going to learn how to solve USACO's 2017 February problem, the bronze level. Number 2, why did the cow cross the road too? It's also called Circlecross. First, we're going to read over the problem together. The layout of Farmer John's farm is quite peculiar. It usually is. With a large circular road running around the perimeter of the main field. And I'm going to start drawing this. By the way, if you don't have a paper and pencil handy, I recommend always having a paper and pencil when you work on these so you can make drawings. The more you can visualize it, usually the better. And I've found that students that draw pictures generally do better on these kinds of problems. So he's got a large circular road running around the perimeter of the main field on which his cows graze during the day. Okay, so he's got this is like a road, like a street that cars are going to drive on. It's a big circle. And then here, there's all the grass. And then we've got cows in here. And all the cows come in here to graze on the grass. Excellent cow drawings. Give him some eyes. This one's happy. Okay, so we've got this circular road. Okay, I'm gonna actually even draw it. Kind of looks like a road. Okay, this is a street. Goes around the perimeter of the field. Every morning the cows cross this road on the way toward the field, and every evening they cross again to leave the field and return to the barn. Okay, so the cows are gonna have to cross the road and then cross back across the road. As we know, cows are creatures of habit, and they each cross the road the same way every day. Same way every day. Okay, each cow crosses into the field at a different point from where she crosses out of the field, and all of these crossing points are distinct from each other. Okay, so let's think about what that means. We've got different points going around the field. I'm just going to draw little dots. It's like this is a place to cross, this is a place to cross, this is a place to cross, here's a place, here's a place, here's a place. We do 1, 2, 3, 4, 5, 6. Let's do 8. Okay, so I've got 8 crossings. I'm just going to go ahead and label them A, B, C, D, E, F, G, and H. Okay, so I've got these 8 crossing points. Each cow crosses in the field at a different point. You cross out of the point. Okay, so each cow is going to cross in somewhere and cross out. Farmer John owns exactly 26 cows and has lazily named the cows A through Z. Not sure what he'll do if he ever acquires a 27th cow. So there are precisely 52 crossing points, okay, around the road. Oh, okay. So actually, really what we have is like an A1 and an A2. Let's rewrite these letters. So I've got like A, B, C, D, and then like A2, B2, C2, D2. Okay, so for example, if Farmer John has 4 cows, then a cow is going to come in on crossing point A and leave also on crossing point A, but we've got like an A1, A2 situation. And then in this case, if I have A, B, C, D, we're looking at like 4 cows. So if we have 4 cows, then we would be able to handle that with 8 crossings. In this case, he's got 26 cows and 52 crossings, but I can't do 26. I can't do 52 letters. So we'll just do 8. It should be around the same problem. And making a smaller version of the problem in a lot of cases is fine. Solving the smaller version is a good way to kind of get some insight on a bigger version. So we've got like an A1, A2, B1, B2, C1, C2, D1, D2. And the cows are going to enter in D1 or whatever, and then exit in D2 or whatever. They'll go from the first one to the second one. Farmer John records these crossing points concisely by scanning around the circle clockwise, writing down the name of the cow for each crossing point, ultimately forming a string with 52 characters in which each letter of the alphabet appears exactly twice. Okay, and they're not even differentiating between A1 and A2. They're just saying there's 2 different A points, and each letter could occur twice. So what they're saying is they're scanning then is, in my example, for up here, for example, if we started here, then this string would be A, and then continuing around clockwise, B, C, D, and then A, B, C, D. So this then would represent this field I've drawn up here, A, B, C, D, A, B, C, D. And then just remembering that it loops around, so this D is actually directly next to that A over there. We're going to write it as a line, but a lot of times when you do this, you'll do this. You'll write something in a line and just make yourself a mental note that it loops, and you can kind of imagine that rather than having to draw it as a circle. It's a little easier way to visualize it. He does not record which crossing points are entry points and which are exit points. Yeah, so we don't have to distinguish between the A1s and A2s. It's just A, B, C, D, A, B, C, D. Looking at his map of crossing points, Farmer John is curious how many times various pairs of cows might cross paths during the day. Okay, so like for example, if cow A comes in here and goes out there, and then cow D comes in here and goes out there, then those cows are crossing paths. we're going to assume they just graze in a straight line as they go from one to the other. How many cows, he says, how many cows might cross paths. So if they have the same start, if they have starting ending points across each other, then it's likely that they're going to cross paths at some point. Let me see, where is it? Might cross paths during the day. He calls a pair of cows AB a crossing pair if cow A's path from entry to exit must cross cow B's path from entry to exit. Okay, so for example, in this case, A, comma, D would be a crossing pair because A goes from here to here and D is going from here to here. Since they potentially cross each other, that's a crossing pair. In this case, I think I pretty much made everything a crossing pair, but it's not, I guess, necessarily the case. For example, if A had an exit and an entrance right next to itself like this, then instead of going through the middle, A would go like this, and then they would not be a crossing pair because A could just go from its entrance to its exit without crossing where D's path is going to be. So that would be an example where it's not a crossing pair. Please help Farmer John count the total number of crossing pairs, how many crossing pairs there are. All right, let's scroll down a little bit. We'll get input output. We're going to clean this up. There's just a note if you haven't noticed this before. The more recent USACO problems use console input and output. The older problems use the file reader. It would be good to know how to do both. But you can check here and it'll show you the input format where it's coming from. In this case, the input and the output are going to come from a file. Depending on what language you're using, you'll have to make a file reader to read this file and write the output to that file. All right, let's see here. Okay, so the input format. The input consists of a single line containing a string of 52 uppercase characters. Now, one thing you can always rely when they've told you something like this, that they're going to be uppercase characters and 52. We don't have to worry about if we've gotten bad input. We don't have to worry about whether or not there's 51 characters or 53 characters. We don't have to worry about some of the letters being lowercase. If they tell you that's the input format, you can trust them that they're telling the truth. This is exactly what we're going to get is 52 uppercase characters. We don't have to sanitize it. We don't have to check for it. We can just rely on the fact we're going to get exactly that input. And that can be very helpful for a lot of your readers if you wanted to make an array to hold. If you're using like the C++ language, you wanted to make an array, I guess, or Java, an array to hold the string. If that was your approach, you could declare the array with the size of 52 right off the bat and read them one character at a time. And you know you're going to have exactly 52 characters. Okay, so 52 uppercase characters. Each letter of the alphabet appears exactly twice. Output format, please print the total number of crossing pairs. Great. So for example, here we have A, B, C, C, A, B, B, blah, blah, blah. And then the sample output is 1. So this is an example of one of the inputs they'll give you, but you will be getting 10 different inputs on this one as well. And there'll be 10 different strings like this. And it will be checking to see whether or not your program calculates correctly based on the string. So you'll need to be able to look at each one of these strings and determine how do you identify that something is a crossing pair. So let's go to whiteboard here. And I am going to write down that string. Actually, I should maybe write that down up here first. A, B, C, C, A, B, A, B, C, C, A, B, and then D, D, E, E, F, F, G, G, D, D, E, E, F, F, G, G. And actually, I'm noticing that this is just double characters, H, H, I, I, J, J, K, K. Remember, we were kind of talking earlier, if you had the path and if you had A entering and exiting directly next door, that can't possibly cross anything. So actually, even though we've got all this sample input, if we think about it, anything where the letter's directly next to itself, that can't cross anything's path, which means we can pretty much ignore these. Now, I can see that these are all like this, and in your code, you won't necessarily be able to read ahead and do this, but just for the sake of the demonstration, we're going to pretend like we already looked at these and already realized that none of these are going to cross anything. After the, let's leave the DD in just because it's like right there on the edge, just to see if it has any impact at all. But I'm already certain that it's not going to. But let's leave it in just to convince ourselves that it won't be an issue. Okay, so if we were to do that, then we're going to get rid of everything down to the DD, and then just trust that all those others aren't going to overlap. But I just want to make sure that you can see that these being bordering each other, it's not going to cause any sort of a special issue. Okay, so back to the whiteboard. Okay, so we've got, oops, let me erase do some of these scribbles. Okay, so we're going to do our road, big circular perimeter. I've got my crossings going A, B, C, C. We'll put the CC, even though, again, we know if it's a direct neighbor. And then A, B, and then DD, DD. And remember then that there was like EE, and then like FF. I'm just going to go ahead and fill up some space. FF, I'm going to really hammer this point in. GG. Okay, so we can just kind of eyeball this and see, yeah, GG, that's definitely not crossing anything. FF isn't going to cross anything. EE isn't going to cross anything. DD isn't going to cross anything. The CC here also is not going to cross anything, but it was right in the middle of our set, so we just went ahead and included it. So really, we've only got one crossing pair, and we can just visually see that. The A goes from A to A here, and the B is going from B to B here, and that's why they cross each other. All right, so that's not quite enough to really see exactly what's going on yet. So let's try a couple different combinations and just kind of see if we can figure out what's going on. So if we have two letters directly next to each other, like CC or DD, we can see that those aren't going to, they're not going to cross anything. But let's see what happens when we put kind of sequences of pairs next to each other. What if I had something like, oops, let me redraw that road. Nice big round road. All right. So if I had something like A and then A, then that's not going to cross anything. What if I have like this, B and B? Is that going to cross anything? C and C, D and D. See, look at that. So if I have them set up like this, I still don't have any crossings because A is going to go to A, B is going to go straight across to B, C is going to go to C, D is going to D, and none of those are going to cross each other either. So that's interesting. So even though we have them separated, they still end up not crossing. So let's look at that versus this. So removing the D's, let's just go up to A, B, C. So the second one I just drew was C, B, A, B, C, B, C. All right. So let's look at these two strings and see if anything catches our attention as far as how we can identify what is really happening different between these two strings. Because the first one with the ABCCAB had a crossing. The second one here with the CBAABC didn't. And if we can figure out why, then we have a solution to this problem. I'm gonna go ahead and erase this letters here, give myself a little more scribble room. Okay, so try to think about what is it, oops, let me see if I can, yeah. Try to think about what actually causes a crossing to occur. If I have a cow that starts at this entrance and walks into the field, right, I'm just gonna walk in. If that cow ends up going back out the way she came, she might not cross, like directly next door, she might not cross anybody. Now, likewise, if that cow goes down this direction and goes out over here, but then the cow in here doesn't go across, then they're not going to cross each other. The crossing is going to occur when a cow leaves and then comes back in somewhere, and then the cow inside has to go across the path, has to go to another one over. Now, if we were to look at just this pattern, and it doesn't have to be exactly these enter and exit points, let's go ahead and even draw them all the way across. If I have one cow that comes in here and then goes out down here, and then one cow that comes in here and goes out down here, they're still going to cross each other. Now, the reason that crossing occurred is because we hit the first cow, and then we hit the second cow, but then before we got to that first cow, that second cow again, we got to the first cow. If we have a first cow and then another cow, and then before hitting the exit of that cow, at any point we hit the exit of the first cow, that makes them a crossing pair. So what your code needs to do is your code needs to look for situations where we've got a pair of letters. For example, C and C. We want to look inside, are there any letters where there's only one of it? Here I've got two A's, I've got two B's. So from the perspective of C, everything that's in here is going to be entering and exiting inside of that same realm and won't be overlapping whatever C does, because none of them are going to have to cross C's path. Whereas in the first string, let me move that over, A, B, C, C, A, B. With regards to the letter A, let me erase this over here. With regards to the letter A, this pair of letters, I have two C's, but I only have one B. Because of the fact I only have one B, that means that A is working in this territory right here, but B has to cross over to be able to get to B's exit. So let's look at that with a couple different strings and think about exactly what's going on here. We're going to have, I'm going to draw a couple different crossing pairs. We're going to have A going to A here. We're going to have a B over here, going to a B over here. We're going to have a C over here, going to a C over here. I kind of changed my mind on where I wanted that one. Let me move that A over a little bit. A, okay. So looking then at this, man, that's hideous. Let me try that again. Okay, fortunately, you don't have to be a good artist to be a programmer. All right, so okay, so we've got the A over here. All right, so I've got A coming first. A, C, B, A, B, C. Okay, so the A is starting here and is working its way to here. Now, if there were any cows that could enter and exit on the same side of the A's path, then that would indicate that in that string, you'd have like A and then that character, you'd have that character again, and then you'd have A. So what we're looking for though, is situations where there's something that must cross. Dang it, lost my circle again. Try that one more time. Come on. They're too close together. There we go. Okay. Okay, so if anything can enter and exit on the same side, then it would be able to not have to cross A's path. But in this case, C, notice from A to A here, I've only got one C, and you can see that's because C is not going to be able to exit on the same side. C is going to have to cross A's path in order to get to its exit. Likewise, B also has to cross A's path. No matter what B does, at some point, B has to cross A's path in order to get to B's exit, because they have only a single letter on the inside there. If I were to switch this up a little bit, let me just draw another one over on the other side here. We're going to do, let's see, over here. We're going to have A, and then we're going to have B, and then I want to put C and C together. C, now let's even do a D. C, D, make a more complicated one. D, C, D, and then A, and then B. This looks like a good one. Okay, I'm going to wipe this guy out over here. So my expectation here is that A is going to connect to A and B is going to connect to B. That'll make one crossing pair. And then D is going to connect to D and C is going to connect to C, making my other crossing pair. As I write this string out, I'm actually going to start from B. I'm going to start in the middle of one of these sequences just to demonstrate that that doesn't have any impact on anything. So we're going to go B, A, B, C, D, C, D, and then A again. Okay, so regarding your data structures, there's a lot of data structures you could use for this. You could use a set. You could have a Boolean array with 26 values. Basically, what we want to do is we want to be able to keep track of what letters we've seen. So, for example, let's say like as I'm reading, I hit the A here, and then I'm going to go find the other A over here and see how many single letters I have in here. And I've got a lot of letters to check. So what I need is some way to be able to add and remove letters to some sort of a container. So if I had a set, that would be a really easy way to do it, because I could just start walking through. I get the B, I add the B to a set. I hit the C, I add C to the set. I hit the D, I add D to the set. I hit C, it's already in the set, so instead of adding it, I remove it. I hit D, and since it's already in the set, instead of adding it, I remove it. And then I hit A, which is where I started. Anything left in here is an item that's going to have to cross in order to get out. And in this case, even though I went from right to left, I went from this A all the way around to this A, this B right here can't get out either way, because it's either going to have to cross over there. I'm doing it on the outside. I guess I should do it on the inside. No matter how I do this, even though A kind of, I guess, maybe I go like that to demonstrate how that works. A goes all the way around. Nothing B can do can get over to the other B, whichever B I start from, without making a cross through that path that A has made. And that's what that leftover B is indicating, is that from A to A, whether I went around this way or whether I went this way, I encountered a single B, and I can't get to the other B without crossing the path one way or the other. It's going to have to cross the path. So if I had a set, that would be an easy way to do it. Another way you could do it, if you're working in a basic language, or if you want to use simpler tools, you could make a Boolean array with 26 values, where index 0 is represented by the A. And the way you could do that is you would just do like whatever your char, if you're doing like C or something, char CH, and then you could do something like CH minus single quote A, and that'll actually subtract and equal 0. So then when you get a letter, for example, when I reach that B, what I could do is go to the index represented by that CH, which is B, minus the capital A, which is going to be 1. I would go to index 1, and I would check to see, is that true or false? If it's false, I can switch it to true to indicate that I found it. And if it's true, I'll switch it to false to remove it. And then once you get done and you reach the other A, you'd have to iterate through the entire Boolean array and see what's true. And whatever's true is a crossing pair. So a lot of different ways to do that. And maybe we can cover that in a details on coding structures video. But regarding the algorithm, though, the only thing we really need is we need some sort of a way to keep track of what we've seen and what we haven't seen. So let's just kind of walk through this whole entire thing and verify we got the right answer. And then I think by now you're probably good to code. Okay, so starting from the B, I have some sort of a for loop that's like maybe I as a starting point. I have a while loop that's going to go forward and find this letter that occurs next, which is going to stop here. So maybe this is J or however you decide you want to do it. Then what I need to do is I need to be keeping track as I go of what letters I've seen. So I've seen the A. The A is going to go into that box, however to do that box. When I hit the other B, I see that the A is in the box. That means that this and whatever's in the box is a crossing pair. So that's found B, A as a crossing pair. I don't actually have to keep track of what the crossing pairs are. Each one's only going to occur. Actually, each one's going to occur twice. That's an important thing to note because B is going to cross A and A is going to cross B. So if I keep track of the crossing pairs, I'll have to make sure to alphabetize them and ensure that I don't have duplicates. Or if I just count, I don't actually even really need to know what the crossing pairs are. I can just say that that's 1. And in the end, I'll just divide that number by 2 because I'll know that everything crossed twice. Okay, let's walk through this on the A because the A is specifically what I wanted to showcase with this one. So we have a for loop finds our A. As we're going through, we're going to keep track of everything we find. We did that just a moment ago. Add the B, add the C, add the D, remove the C, remove the D, reach the A. That's a crossing pair. So then that now becomes 2. For the second B, this is actually kind of important to note. For letters where it's already been found, if you wanted to have a structure keeping track of which letters you've already solved, you could do that. But actually it doesn't matter because as I send that seeker out to look for that other B, because of the fact that this loops, I actually can take advantage of the fact that as a linear version, it doesn't loop to indicate that this is the second one. We kind of talked about that earlier. This first or second one doesn't really matter, but if this is the second one, that means the first one is already matched to it, which means anything that matches to nothing and gets to the end and didn't find itself, that's already been done. So it means we don't have to do it again. We could optimize that a little bit, but actually it turns out it doesn't really matter. As far as the runtime complexity, because this is a set 52 characters, even if you're in n squared, that's going to be 52 squared, which is not that big of a deal. That's a tiny number. Okay, picking it up. So from the B, just to walk through the process, you would add the C, you would add the D, you would add the C, or sorry, you would remove the C because we already added the C. You would remove the D. You would reach the A, you'd add the A, but then you get to the end of the string and have not found a second B. Because of that, we just throw out whatever's in the box and we don't count that as anything because that's already been handled. And again, that's extra work, but the computer's not going to mind. Starting from the C then, we have the C, we add the D, we reach the C. The C is what we started on, which means we have 1 item in the box here, the D, which becomes 3. And by the way, again, we don't have to keep track of what the letter is. We just have to count that how many things are in the box at the end. Picking up from the D, D is going to do the same thing. D, add the C, hit the D, 1 item in the box. That's going to become 4. Moving on to the next letter. C is going to search out, add the D, add the A, but then not find a C and then throw out everything in the box. D is going to add the A and then not find anything and throw out everything in the box. And then A is the last letter. Actually, at this point, you probably could cut your for loop off with the last 2 things because the last 2 things aren't going to have a crossing pair. But anyway, even if you run all the way up to the end, the A is not going to add anything to the box and it's already at the end and then nothing happens. So your final answer then was 4. The reason that happened is because I got A crossing B and B crossing A. I got D crossing C and C crossing D, which was 4 total crossings. But I only want to know the number of crossing pairs, which is half as many. So I would just divide that by 2, giving me 2, and that'd be my final answer. All right, I think you're good to code this one. And if you have any difficulty, be sure to check in on the coding section.